Hello friends. Now this is the fourth video of capacitance. Here we will discuss about the equivalent capacitance, and this is the first of equivalent capacitance. Okay. Now in this video we will deal with a bridge circuit, star circuit and a delta conversion. Now all these circuits, four circuits given, they are called bridge circuit. They are exactly same circuit but in different shapes. Okay. Now just you arrange this A. This point is you put B. This is A. This is B. A to D there is a capacitor. Then B to D there is another capacitor. I am giving C to C2. Similarly, from A to E there is a capacitor, that is C3. Then from B to E there is a capacitor C4. Sorry, A to E this is C3. B to E this is C4. So in between D and E this is C5. Okay, so this is C1 C2, this is C3 C4, this is C1 C2, this is C3 C4, and in between D and E this is C5. Now if you imagine in another way, that is connect a cell to A and B. If A is positive, B is negative, so this is plus plus, this is minus minus, then this is minus means minus minus, this is plus plus. Therefore at the point D you will feel minus and plus combination. At the point E this is a minus and plus combination. If you imagine C1 equal to C2, then potential at D is 0. If you assume C3 equal to C4, potential at E equal to 0. But at D and E, potential may not be 0. But if the potential at D is exactly equal to potential at E, this is possible. If this is possible, Vd equal to Ve, if C1 by C2 equal to C3 divided by C4, and this is called conditions of balanced bridge. This is called conditions of the bridge. Okay, that means in this case no charge that is flows across D and E branch, across D and E. Therefore, you can neglect this capacitance. This capacitance, you can neglect it. Okay. If you neglect this capacitance, then the equivalent capacitance now becomes, this is C1, this is C2 equivalent circuit, this is C3, then the fourth one is C4, then this side is B, and this side is A. Okay. Now see, from A to B, path 1 you can move. From A to B you can move through path 2. Now both the two paths are there parallel, and in one path there are two capacitors. They are in series, and these two are in series. Okay, and these two paths they are in parallel. So it is possible to calculate what is the equivalent capacitance if C1, C2, C3 and C4 are given. C5 may not or may be given or may not be given, but it is not used. Okay. Now that is some problems for you. Work out. This is then just some examples. Let us take, if you take C1 equal to C2 equal to C3 equal to C4 equal to C5, all equal to C, then find CAB, find out the value. A problem for you. Let us try, and answer is C. You derive and check it whether the answer is wrong or right. Then second question is, C1 is 2 microfarad, C2 is 4 microfarad, C3 is 3 microfarad, and C4 is 6 microfarad. So C5 is not necessary because C1 by C2 equal to C3 by C4. Okay? So in that case, you find out what is CAB. Check it. Answer is 10 by 3 microfarad. Whether the answer is wrong or right, you can check it. And another one is third example. That is, I am giving here. C1 is 1 microfarad, C2 is 2 microfarad, then C3 is 3 microfarad, C2 is 3 unit, C2 is 3, C3 is 2 microfarad, and C4 is 6 microfarad. C1 by C2 ratio is 1:3, C3 C4 ratio is again 1:3. Solve this and you will get the CAB that equal to 2.25 microfarad. Now check whether the answers are correct or not. Now the second is, this is a star circuit. These two circuits are exactly same. Okay? Now if you see, observe this circuit. There is an extra capacitor in between A and B, and if you take this portion of the star, now this is a bridge, Wheaton's bridge. Okay? Now you can plot this equivalent diagram H. This is C1, this is C2, this is C5, then this is C4, then this is C3, then this point is A, this point is B, and at last there is a capacitor C6 between A and B. So this is the star circuit. Therefore, if you connect a sixth capacitor parallel to the bridge, then it becomes a star circuit. So how can you solve it? Exactly by similar method, bridge circuit. If you assume that if C1 by C2 equal to C3 by C4, then potential across D equal to potential across E. This is D, this is E. Therefore, C5 can be removed. It is not effective, not working in the circuit. Therefore, here you can take, this is C1, equivalent circuit is C1, C2 parallel, then C3, C4 parallel, and at last C6 is parallel. So this is A, this is B. So from A to B, how many paths are there? This is path 1. Two capacitors are series, find out equivalent. Path 2, two are series, find out equivalent. And this is path 3, and all the paths, they are parallel. All the paths are parallel. So at last you can find out what is CAB. Okay? Now if all the capacitors are identical, I am writing for identical capacitors, C each, so CAB that equal to 2C. You solve, put all are C, then find out the answer is 2C. You check whether it is a wrong or right. So you can solve that star circuit just connecting a sixth capacitor across the bridge AB. Okay? Now let us discuss with a circuit delta conversion. What is a delta conversion? I am taking same bridge circuit, but delta conversion is, you can use this principle. Condition if C1 by C2 is not equal to C3 divided by C4. If these two are not equal to, then in that case potential across D and potential across E are not same, if they are not same, charge flows across D and E. Okay? If charge flows across D and E, so you cannot neglect C5. Now there are two methods you can use. You can use Kirchhoff's laws, first law, second law to solve this problem, but I want to solve this problem by using delta conversion directly. Okay? What is a delta conversion? Delta is this type of a symbol. Now just mark, I am taking, this is my delta. This is delta. Just imagine, I am taking, this is a symbol. Okay? Just you put a delta mark. Then equivalent circuit is, before drawing equivalent circuit, assume a capacitance C that equal to C1 plus C2 plus C5. How many capacitors are there in delta? There are three branches. This branch equivalent to this branch. This is a T-type body. C1, C2 and C5. Three capacitors are within delta. So you put C equal to C1 plus C2 plus C5. So now as per the principle, the first line is this is the first line. This is first line. Then C2, C5 this side. C2, C5 this side, and this is this side. Then C1, C5 this side. So this you take C1, C5. Okay. This point is your E. Then this is capacitance C4 and this is capacitance C3. You can join. This is B and this is A. This is your equivalent circuit. Now if this is the equivalent circuit, then what is the capacitances of these three? The first one is, this is C1, C2, product of these two divided by C. Now this branch capacitance is C2, C5, these two, same side, C2 into C5 divided by C, and this side C1, C5, this is C1, C5 divided by C. These are the capacitors. So you can convert by using delta into equivalent form. Now assume this capacitor, these two ends are connected directly to this side, these two are connected directly to B. So therefore I think these two are parallel and these two are parallel, they are parallel. Okay, so solve another circuit, another equivalent circuit is, that is, this is capacitor, this one, what we call C1, C2 by C. Then these two are parallel, this is A, this is first one is C1, C5, this is C1, C5 by C. The second one is C3, these two are parallel. Then this is series with this one, this is another capacitor is C2, C5 by C. Then it is parallel to C4. This is your point B. Okay. Now from A to B, how many paths? Path 1, path 2. Therefore in path 1 there is one capacitor. You put C1 into C2 divided by C. You can find out the value of this capacitor. Now along path 2, these two are parallel, these two are parallel, and these two in series. Okay, these two are series. This is parallel, and these two are in series. This is series, and these two are parallel. And finally, path 1 and 2. This path is again parallel. So you can find out what is the equivalent capacitance. Now in this case, calculation calculation may be somewhat tedious, somewhat difficult, but it is possible to solve this delta conversion if the bridge does not obey Kirchhoff's law, the conditions of the bridge. It violates the conditions of the bridge. You can use this type of a formula. Okay. Now some problems for you. That is number 1. If you take C1 to C, C to C. Suppose C1 is to C C2 is C, C3 is C, and C4 is 2C. Okay, C1 2C, C2C, C3C, C4 2C, and C5 is again 2C. C5 equal to 2C. So in that case, CAB, by same method, you can find out CAB that equal to 10 by 7. 10 by 7C. This is problem 1. You check it whether the formula is wrong or right. The second one is C1 is 1, C2 is 3, all are microfarad, and C4 is again 1, C4 is 3, and C5 is 1. C1, C2, C3. C3 is 3, C4 is 1. Okay? C1 is 1, C2 is 3, C3 is 3, and C4 is 1. Then C5. C5 you put 4 microfarad. So find out CAB, equivalent capacitance, and calculate, solve, check it whether the answer is 11 by 6 microfarad or some other else. And another problem for you. Okay, C1 is 8, C1 is 8, C2 is 10, C3 is 2 microfarad, C3 is 2 microfarad, C4 is 4, C5 is 6, C4 is 4, and C5 is 6. Okay, now check what is CAB, find out the value of CAB, and I think I do not give you the answer here, you calculate and check it. Okay, and you can find out, I think this problem is this is in your concept of physics HC Burma, this is. Okay, okay dear students, if you like this video, like it, share it, thank you.